Hello, my students, and welcome to this episode. In this session, we are going to discuss the equilibrium of a rigid body under the effect of two forces or three forces meeting at a point. So, imagine that we have a smooth horizontal plane, and there is a sphere placed on this horizontal plane. We say that this sphere is in equilibrium if the resultant of the forces that effect on it equals zero. So what is the meaning of equilibrium? Equilibrium means the resultant force equals zero, or is the resultant force. So as you see here, what are the forces that affect on this sphere? We have weight, and the weight of the sphere works downwards. And also we have the reaction. The reaction of what? The reaction of the horizontal smooth plane. And the reaction works upwards. Okay? Because this sphere doesn't move. So we say that this sphere is in equilibrium. We have under the effect of two forces, we have weight and R. And in this case, weight W equals R. R is the reaction of the horizontal place. So we say the rigid body is in equilibrium under the action of two forces if the two forces are equal in magnitude. If the two forces are equal in magnitude. And they are in opposite directions. They are in opposite direction. And the lines of action are on the same straight line. The lines of action are on the same straight line. Let's analyze it. Look at this sphere again. We have two forces. Okay, the first force is the weight of the sphere, and the weight is working downwards. The line here of the force is down. And the reaction of the smooth plane, the reaction works upwards. So as you see, because they are equilibrium, the two forces, or the sphere is in equilibrium, so W equals R. Now, we can say they are equal in the magnitude, number one. And as you see, they are in opposite direction. Number three, the line of action are on the same straight line. The line of action, as you see, the line of action of R and W are on the same straight line. Okay. What if we have three forces? This is the body. I'm talking about this body here. Okay. And the body is in equilibrium under the effect of three forces. I'm talking now about three forces. So, if three coplanar forces, F1, F2, and F3, are acting at a point, and they are in equilibrium, like here we can write F1 in this direction, here and here F2 in this direction. that is F2, and we have F3 in that direction here, F3. What does it mean? Because I said the three forces which are acting on this body are in equilibrium. What is the meaning of equilibrium again? Equilibrium means the resultant force of the three forces equals 0. That means the resultant force of F1 and F2, the resultant force of F1 and F2 equals to F3 in the magnitude and in the opposite direction. So we can just represent the resultant force of F1 and F2. We can represent it in this direction here, as you see here. Look. This is the resultant force of F1 and F2. As you see, we can write R1 and 2. And R1 means the resultant force of F1 and F2. As you see, I've drawn the resultant force in the same line. They are lying on the same straight line, okay? And they are in opposite direction. So in this case, F3, the force 3, is the same as the resultant force of F1 and F2. We can write it as R1 and 2. So F3 equals R1 and 2. Once again, if I tried to find the resultant force of F1 and F3, so what is the direction of the resultant force of F1 and F3? Look at F2, because I'm going to find the resultant force of F1 and F3. And I said the body is in equilibrium. That means F1 and F3, we can just write the resultant force, or we can represent the resultant force of F1 and F3 in this direction. So look at F2 well. I'm going to go in the same line here. This is the resultant force. So they are lying on the same line and in opposite direction. We can write here R1 and 3. That means if you found the resultant force of F1 and F3, you will find the resultant force here of both of them is the same as F2 in the magnitude. Okay, but they are in two different directions. Let's take this example. F1, F2, and F3. We have three forces, three coplanar forces meeting at a point, Okay, the magnitudes are 12 root 3 and 24 newtons okay, respectively. If the three forces are balanced, the three forces are balanced. What the meaning? What is the meaning of that? The meaning of that, if the three forces are acting at a point or acting at a body, a rigid body, so they are in equilibrium, F1, F2, F3. The body doesn't move because the three forces are balanced or are in equilibrium. Find the measure of the angles. Find the measure of the angles between them, between the three forces. So suppose that F1 and F2, the angle between them, we can write here angles like theta 1 here between F1. Here, let's write here theta 1. This is an angle between F1 and F3. Okay, and here we have an angle like theta 2, and here the angle is theta 3. Okay, so the resultant of F1 and F2, look at F1. F1 equals what? Equals 12. So here is 12. F1 is 12. And F2 is 12 root 3. F2 is 12 root 3. That is F2 12 root 3. And F3 is 24. That means the resultant of the two forces, 12 and 12 root 3, is the same as F3 in the magnitude. So R1 and 2, the resultant of the force 1 and the force 2, okay, must be 24. But in this direction, look at the direction of F3. I assume that F3 works downwards here. So the resultant of F1 and F2 is going to be working upwards here. So this is R1 and 2, the resultant of F1 and F2. Okay, so R1 and 2 is 24. Okay, so we can find now the angle between F1 and F2. You know this rule, which is R equals R to the power of 2 is the same as F1 to the power of 2 plus F2 to the power of 2 plus 2 F1 F2 cosine theta. Okay, so we can find the angle between them. So right instead of R, we write 24. Why is that again? Because they are in equilibrium. They are balanced. So F1 and F2, their resultant is 24. And F1 is 12, so write 12 to the power of 2 plus 12 root 3 to the power of 2, okay, plus 2 multiplied by 12 root 3, then multiplied by cosine theta. Tied it up. This is 24 to the power of 2. So 24 to the power of 2 is 576 equals 144 plus 433. You can use your calculator to find the answer quickly. And here we have 288 root 3 cosine theta. Tied it up by adding here them. You will end up with cosine theta equals 0. Okay, because this is 576. 144 plus 443 is 576 equals here 576 plus 288 root 3 cosine theta. Move it to the next side. So 288 cosine theta equals 576 minus 576, which is 0. We can write it here. So 288 root 3 cosine theta equals 0. Then divide by 288 root 3. You will end up with cosine theta equals 0. So the size of this angle theta equals 90. So I managed to find the angle between F1 and F2, which is 90. What is the next step? The next step to do the same steps depending on your knowledge, which is I have here 12 and I have here, this is the angle is 90. I found it, this angle is 90 between F1 and F2, and this angle is 12, this force is 12, and this force is 12 root 3. This angle is 90. And this force is 24. And don't forget, they are in equilibrium. And they are meeting at a point. Now let's assume that this force 12 and 24, okay, both of them, their resultant will be what? 12 root 3. So I'm assuming that R here, the resultant of the two forces is going to be 12 root 3, but in this direction here. So the resultant of the two forces, 12 and 24, is going to be what? 12 root 3. This is the resultant force. Why is that? Because the three forces are balanced. So the resultant here is 12 root 3. I want to find the angle between them. We will follow the same steps, which is r to the power of 2 equals f1 plus f2 to the power of 2. What is the r? R is the resultant of 12 and 24. What is the resultant of them? Is 12 root 3. So r to the power of 2 equals, okay, 12 to the power of 2 plus 24 to the power of 2 plus 2 multiplied by 12 multiplied by 24 cosine theta. So what is r in this case? R is 12 root 3 to the power of 2. Okay. Following the same steps leads to get the angle between them, and after that you will subtract 360 minus the sum of the two angles you have got, which is 90 and this angle. I hope you enjoyed this session. See you in the coming episodes. Goodbye.